Okay, last problem, or the second problem on the back flap of your Unit 9 Circles flipbook. Here's the question. A satellite orbiting the Earth calculates that the shortest distance to the Earth is 6,400 miles, and the distance to a point tangent to Earth is 11,140 miles. Use this information to calculate the approximate radius of the Earth. Now, the first thing I want to let you know about these kind of questions is they are not to scale. This satellite, if it were orbiting the Earth, would look like it was a whole lot closer. It'd be around here somewhere, actually orbiting the Earth. But because we want to have some room to draw our information, we move the satellite way out into space. But I want to let you know that, class, that when you draw these lines, they're not going to look normal. It's because this particular drawing is not scaled properly. It's not a dilation of the actual satellite orbiting the Earth. Alright, so let's draw on the diagram what we know. So the first thing I'm going to draw is, let's draw a line segment from the satellite to the center of the Earth. And I'm going to note something, class, very important that you understand this, is that it says it calculates the shortest distance to the Earth. That's actually to this point right here. That's the shortest distance. That's the closest point to the Earth. So actually this 6,400, I'm going to label this right here. This 6,400 miles is actually the distance from the satellite to this point. It's not to the center. Alright, we got one more point we're going to go ahead and draw a line to, and that is to the point tangent. Now I put a point on here already so you can make sure you get that accurate. So there is a point tangent to Earth, touches the Earth at one point. And we have found out that that distance is 11,140 miles. Okay. Well, we got to find out the approximate radius of the Earth, and to do that, we have to remember our rules of tangents and radii. If you have a tangent to a circle and a radius of the circle touches the point of tangency, that creates a right angle. We've already had that shown in class. We've used that. So let's go ahead and make a right triangle out of this. So I'll go ahead and draw that radius. And again, based on this rule, this tangent radius theorem, we know that this angle is a right angle because a tangent and a radius that touch at a point of tangency create a right angle. They will always create a right angle. And then last thing I want to do, class, is let's label the radius. This distance from this red point to the center, I'm going to label that with a small r. And then this distance from the center to the point of tangency, I'm going to label that as a small r. It's a radius. Both of those are the same variable. They're both a radius of the Earth. All right, let's go ahead and see if we can calculate what this radius is. One more thing I want to note is I certainly want to know what my hypotenuse is. And I can tell you right now, if you look at the right angle, it's the side that doesn't touch the right angle. That means this is the hypotenuse. Very important to note that, because easy with this triangle to think the top line is a hypotenuse, because the thinner these triangles get, the more these two angles right here are going to look like right angles. But this is our right angle right here. There is our right angle. Okay. Well, we have a right triangle. I think it's hopefully clear to all of you. We're going to use the Pythagorean theorem. So let's do that. A squared plus b squared equals c squared. And let's take a look. A squared is going to be one of the legs of our triangle. Let's pick this one right here, the 11,140. We're going to square that number. B squared is actually going to be this leg right here, which happens to be the radius. So that's going to be r squared. And now here's the tricky part. The hypotenuse is not 6,400 miles. It's 6,400 miles to this point, and then r to this point. So the hypotenuse, we have to add those two things together. So it's going to be r plus, if I can get that written clearly so you guys can see it, it is r plus 6,400, and then of course that's going to be squared. So C is r plus 6,400. Now this looks complicated, class. The cool part is though you've already learned all these math abilities. Let's go ahead and solve this equation for r. Now I can go ahead and square 11,140. I'm going to tell you right now that is one big number, and if you write down one number wrong on that, you're going to end up messing up your problem. So I'm going to hold off on doing that, save myself a little bit of time. So I'm just going to write 11,000. Let's try a different color here. Let's go to blue, and then we'll go back. So we're going to write 11,140. Again, let's try to keep it neat so you guys can read this. 11,140 squared plus r squared. Remember that when you square a binomial, all you got to do is write it twice. R plus 6,400 times r plus 6,400. Okay, let's go back to orange and let's write this again. This is just 11,140 squared plus r squared equals, let's do our distribution. If you remember how we did this when we were dealing with quadratic equations, we take the r and that combines with the second binomial, and then we take the plus 6,400 and that combines with the second binomial. Remember doing this a couple units ago. Now I know you can use FOIL in this case to solve this, but I want to just keep consistent with what I've been teaching you guys, a procedure that always works, whereas FOIL only works with two binomials. Okay, let's go to the next step. We got 11,140 squared plus r squared. Let's distribute. R times r is r squared. R times 6,400 is 6,400r. 6,400 times r is 6,400r, and 6,400 times 6,400 is just 6,400 squared. Again, I could multiply those out. I'm going to get like 40 million something. I'm going to leave that as a square. Okay, now something you should notice here, class, is we've got like terms over here, 6,400r and 6,400r. Those I can combine. And let's take a look at this. We've got r squared on the left side and r squared on the right side. If I subtract r squared from both sides, let's do this. If I subtract r squared from this side, and I can subtract r squared from this side, there's really no room to do that. Actually, let's do it like this. You can see this. I'm going to subtract r squared from this side and subtract r squared from this side. And when I do that, let's write our new equation. Now I've got 11,400 squared. Oh, my r squared disappears. My other r squared disappears. Let's combine these two together. 6,400 plus 6,400 is 12,800 r. And then I've got this 6,400 squared. We're getting close now. Okay, now I think you guys can see we are going to subtract 6,400 squared from both sides because these are like terms. They're both just constants with no variable. So subtracting that from that, guess what? I'm going to save the trouble of having to actually calculate this big number out, and watch what I'm going to do here. Let's move my calculator over. So let's take 11,400, You know what? I wrote that number down wrong. Hang on a second. Just realized that. Let's fix that. Boy, see that? See what I told you before? You start writing big numbers down, it is easy to write them down incorrectly. 11,140 squared. All right. So I'm going to subtract 6,400 squared from both sides. Let's put that in our calculator. 11,140 squared minus 6,400 squared equals 83139600. I'm guessing that must be correct. All right, so let's write that in. 83139600 equals 12,800 R. Last thing we have to do is divide both sides by 12,800 because that's how we're going to get R by itself. So let's go ahead and do that. See if I still have that number in my calculator. Yep, 83,139,600. Then we're going to go ahead and divide that by 12,800, and we get 6495.2 or 6495.3. So R, let's see if we can write this in. R is approximately, let's bring that up one more time. 6495.3, 6495.3. So our final answer is the radius, or the approximate radius of the Earth is 6,495.3 miles. And I can tell you that's actually pretty darn accurate, pretty close to the actual radius of the Earth. So if you look through these steps again, class, start with Pythagorean theorem. Here's our crazy part. Our C is equal to these two numbers, R and 64 added together. I just went through the steps. I distributed two binomials, combined like terms, got rid of R squared because it was on both sides of the equation, subtracted 6,400 squared from 11,140 squared, and then this big number, all we had to do was divide both sides by 12,800. And if you want to put commas here just because you can see the size of these numbers better, we can put a couple commas in here. We can put a comma at 6,495. I think I've done that for the rest of the numbers. So here is how we solve the Earth's radius using data from a satellite.